pump. So it means it needs ATP. So using ATP, we resynthesize this one. So become ADP. But ADP to be ATP, we can use creatine phosphate if we have, and become creatine. But if we have this, if we have really developed mitochondria creatine kinase also, right? So this creatine get inorganic phosphate from creatine kinases on the mitochondria. So I really want to say creatine phosphate or creatine is not for only high exercise intensity. We need any right? Even at rest. Does it make sense? Does it make sense? So true first quiz. I think Adam will be incorrect. Right?
So is that creatine kinase, is it on the mitochondria?
On the mitochondria.
Okay.
Around 4% of whole mitochondria. So 97% in the cytosol. But 4% is on the mitochondria. Another percent in the sliding filament theory, like actin and myosin around there.
Okay.
So how about if we do not have enough mitochondria, we just using creatine phosphate in cytosol. I think I forgot here. See, because you put the I put the ATP, right? So this is not even ATP hydrolysis, but release one proton from this fructose 6 phosphate. This proton from the glucose, right? So we still release protons and 1 minus ATP, right? Yeah. I want ATP, but we need ATP. So fructose 1,6-phosphate, right, is become glycerolaldehyd 3-phosphate, but G3P is totally okay, but this one is DHAP, and DHAP is not really stable, so become G3P and G3P, is right? Okay. So this is really important, right? Stage 6. Step 6. So it releases one proton from the G3P and it needs another thing as a substrate. Did you remember? Because together ATP, we need another one, is right?
Phosphate.
We need phosphate. So inorganic phosphate we need here. Inorganic phosphate we need here. And it releases one proton from G3P, another proton from inorganic phosphate. And how about this inorganic phosphate from where? ATP hydrolysis during high exercise intensity. It means if you stop exercise, no more substrate. So stop this reaction. Glycolysis stop, right? So this inorganic phosphate actually from to here. Wow, it's right now it's very makes sense, is right? We use ATP through this reaction with proton and here is right. Well, how can you use inorganic phosphate? Yeah, that case here I forgot to put here this inorganic phosphate to here too, right? When we make glycogenolysis, right? So without high exercise intensity, we do not have any inorganic phosphate, so we cannot use glycogen. Yeah, it doesn't make sense. Doesn't make sense. This is why we must use glucose, put the another inorganic phosphate, is right. Or just using energy from fat. But the problem is we are exposed to too much carbohydrate. This is why our insulin concentration is always high. But this insulin is anabolic hormone, so it's a preserve energy from the fat, is right. So we cannot use fat. So this is why you should keep eating, keep eating. Still your muscle starving, but you must keep eating. Right? That is the problem. So we must know, oh, glucose is very tough to use. If we know this one, we cannot eat that much glucose. But 1977 or 78 is American government published like a food dietary guideline, is right. They put, I think 55 to 65% energy should from the carbohydrate, is right. There are no research. That was surprised. To criticize, I tried to find what is kind of research. No research. And finally, I understand. Oh, there is guideline. Guideline is consensus, is right? Doesn't make sense. There is agreement. They do not need research. Right? But we just believe, oh, guideline is they study a lot. No, it's not really studied. Anything question from which? Is it okay? Is it okay? Yeah. Yeah. You should draw together, right? Yeah. It's a lot.
So are two hydrogen ions released from that G3P?
One from the G3P, another one from the inorganic phosphate.
Oh.
Yeah, different. And how about, because it releases, right? So, but these two proton, and actually I didn't write down here, but there are two electron. It should go to the mitochondria, right? So which coenzyme we need, right?
Oh, NAD.
Yes, NAD plus, right? It's metabolic taxi. So how about please watch here. NAD plus, please watch here, right? NAD plus, right? It means we have one less electron, is right? NAD plus means less electron, one electron less, right? But it's become NADH. How about here? NADH, right? So there are no positive ion. It means he got a or she got some electron from the here, and what is this? This proton, right? This one actually is a positive proton become just hydrogen. It means it has another electron, is right? And just positive proton, right? This proton doesn't have electron. See? So this is why when give to the proton and electron, right? These two proton and two electron go there. Even we do not write down here, but you should understand. Does it make sense? Yeah. But many textbooks didn't explain this one, why this electron is right. This is why we couldn't really understand electron transport chain, right? Why this is important? Because they want to transfer electron. But in the book, they couldn't write down is right this, but actually they are electron. Right? Why this metabolic text go to the mitochondria to give electron and two proton? But yeah, already textbooks write this, so we forgot to there are electrons, but actually there are electron, right? So two electron and two proton go there. So how about so right now, so we have another inorganic phosphate is right. So we have another inorganic phosphate right now, two phosphate. Right. So 1, 3, this phosphoglycerate. I do not ask you like write down is write this, but it really help you to understand. Right? And it's time because we have enough inorganic phosphate, so using ADP and become ATP. So we use just one inorganic phosphate from the here. So it's right now only 3, right? So 3 phosphoglycerate. And this one is moved to the here. This is more stable, right? So 2 phosphoglycerate. And still same, but change the structure is PP, right? At that time, release one water. And this PP, when become pyruvate, we need another ADP and get a last phosphate group, so become ATP. This Is okay. Glycolysis is right. So we already used 1 ATP. Another is 1 ATP, but here we have 2 ATP. We have another 2 ATP. So 4 ATP, but 2 ATP. So net is 2 ATP. Yeah, do you agree? Do you agree? But this glycolysis, how about glycogenolysis? How many ATP?
3.
Yes. 3 ATP glycogenolysis. And another one, how about how many NADH plus proton? From the one glucose molecule?
2.
Yes, 2 NADH plus proton. And anything else? 2 water, 2 pyruvate. This 2 pyruvate become acidic, 2 acidic conjugates, right? So it's here, right? But during high intense exercise, during high exercise intensity exercise, right? It cannot go this way. So during high exercise intensity, because mitochondria is so busy, right? During high exercise intensity, right? So yeah, but this is not first time, right? I believe you understand, right? So during high exercise intensity, NADH plus proton give 2 proton and 2 electron to the pyruvate. So pyruvate become which molecule?
Lactate.
Yes, lactate is right. Oh, again. Oh, it means lactate is pyruvate. Lactate consume proton is right. Consume. Oh, another buffer. Third buffer. Right. So actually, creatine kinase is buffering, right? And AMP deaminase is buffering, is right, using proton. And lactate actually is buffering because to consume 2 proton. It's really good, right? And NAD plus because give 2 proton, 2 electron is lactate, so it can go again step 6 to get more proton, is right? That's good. So lactate formation is really important to continue glycolysis, is right? This is important. And actually, lactate is interestingly, lactate is negatively charged, right? So there are some kind of shuttlage here, right? We call MCT shuttle, right? Monocarboxylate, I think transporter, right? This one, lactate, when lactate go outside, there are another positive ion go to outside too. Did you remember? Because like mass reaction, this is important. But if we have increased lactate, it's not good, right? It should be go outside. So to go outside to the muscle through this shuttle, right? But this is shuttle, negative charge go outside, but there are another positive charge should go outside together. That is
Proton.
yes. It is. This proton and lactate go together, right? So this is why in the blood there are lactate during high exercise intensity and proton. This is why scientists is confused, right? Confused.
What is the MCT?
It's a monocarboxylate transporter, right? It's kind of a shuttle, right?
Yeah.
I think MCT is totally okay.
Works for me.
Yeah. So it makes sense, is right? It makes sense, right? But interestingly, this MCT channel is not only from the muscle, between muscle to the and blood. This is the muscle to muscle, right? This is muscle to muscle. And how about, it is like this. How about, this is the, right? How about here? This is another muscle fiber is here. And it sounds like, right now high intensity occurs, right? It sounds like this is FT fiber. And how about this is slow twitch fiber, right? How about this is FT fiber, this is slow twitch. FT fiber characteristic is glycolytic characteristics, right? Less mitochondria. So less mitochondria. But slow twitch, right, is not strong, but it has many mitochondria, right? A lot of mitochondria, right? So that case, MCT, so here too. So during high exercise intensity, this lactate and proton can go to the slow twitch muscle fiber, right? And lactate and proton, right? Lactate can become pyruvate and enter mitochondria, and proton can enter mitochondria. So this is why HIIT program, high intensity interval training program, high intensity exercise, release lactate and proton. During slow exercise intensity, right, using slow twitch muscle can get a lactate and proton used as a substrate in the mitochondria. It makes sense, right? Give a lot, but many times, like a training program, they said exercise and rest. It means there are no slow speed. That is like they just walking or just stop exercise. That case, their mitochondria is not activated. Is right. So we need a little bit higher speed, right? Any questions so far? Any questions so far, right?
I'm sorry.
Yeah.
And I kind of vaguely remember it from last lecture. You had said lactate and hydrogen act as a substrate in the slow twitch muscle from the fast twitch.
Yes, it's possible. Yeah.
Okay. Is it just like
Lactate shuttle. We call it lactate shuttle.
what's the process for using that as, I guess, a substrate? Like, is it a substrate for?
Just through TCA cycle.
Okay.
Yeah,
That
become
makes sense.
pyruvate.
Yeah.
Yeah,
Okay.
yeah.
There we go. There we go.
Right.
Okay.
Because there are demand.
So it's just a one step to pyruvate.
Yes.
Okay.
Yeah, right. But the problem is, but if you just, how about high exercise intensity, lactate and proton? But if you just stop, slow twitch is not activated, right?
Yeah.
So there are no demand. So that should be going to in the blood. But if you keep exercise slow speed, right? That case you can still, there are demand is a mitochondrial response system. So we can use this lactate and proton from the FT fiber. This is why our job is to set up this speed. This speed as well as this speed, right? It doesn't make sense. Doesn't make sense. So after exam 1, so we'll talk about that more. HIIT program, how to make HIIT program, how to make a HIIT program exercise intensity. And another one, how about, did you remember size principle from exercise teacher, right? But many times with size principle, we do not really teach well because maybe, I think here is